Good morning everyone. My name is Dr. Manish Kumar Rai. Today we are going to talk about the OT ICS server types. Let me just describe what is OT. OT is a operational technology or industrial control system. Basically, that power grid, that water distribution plant, manufacturing plant, railway, transportation sector, you can consider them as a operational technology. Means OT infrastructure you can call. Basically there are two types, IT infrastructure or OT infrastructure. So in IT generally we deal with the data, like every department is having their own data, so keeping data comes under the IT, that managing the network in that IT infrastructure, like in office where we are doing the general work or paperwork, so that just come under the IT part. OT where that the manufacturing, that the generation, that these comes into the existence, then we call these network as a OT network. Because OT components, the only server, system, firewall, these came into the picture. When we talk about the OT, then the PLC is SCADA. PLC is the programmable logic controller through which we are controlling the actual mechanical process. So these come into the existence where we are controlling these hardwares, these mechanical arms through the software or through the control signal. So that network just become the OT network. And nowadays the attackers are not only targeting the IT infrastructure for the data, but they are actually targeting the critical infrastructure like railway, power grid. And we have seen that these attacks during either during Operation Sindoor or during the Russia and Ukraine war, or in any war in the country, we have just witnessed that these kind of attacks were reported during that days. So in this particular session we will talk about the 157 types of server from the 18 different categories, and 15, we'll just consider 15 sectors. So now you can assume that in OT infrastructure more than 157 servers we are using. And in this video series we will talk about the each servers and what is the significance of them, why they are unique, what is the functionality of that. So in Purdue model, according to the Purdue, we can divide that complete OT infrastructure into multiple labels. So it just start from the level 0. So level 0 is a physical process. This is a real industrial world where actual process happen, like power plant. Temperature sensor measure the boiler temperature, valve opens steam flow, motor drives conveyor belt. Which devices are we are using at this particular level? Sensor, actuators, motors, valve and smart meter. So generally at this particular level there is no server we are using. These are actual components. Now when it comes to the layer 1, so this layer directly controls the machine and physical process that are present at level 0. So which devices we are using at level 1? So there is PLC, RTU, distributed control system, safety instrumented system, intelligent electronic device, phase measurement unit. So for example, let us suppose if we continue the last example, that a PLC receives temperature from level 0. Like for example, these are the sensors and all. So this PLC receives data from this sensor that the current temperature is this. Now what you can do, that the PLC either can send on or off signal to the actuators, and this actuator can switch off or switch on that particular motor physically. Next layer is level 1.5. So this level is a communication and gateway, because we must have to transfer this communication to the upward, to the SCADA server. So for that it acts as a translator and communication bridge between the OT devices and the higher systems. And which components we can use at this particular level? FEP, that is front end processor, OPC servers, protocol gateway, MQTT broker, edge servers, API gateways. Okay, like for example, a Modbus PLC communicate with the SCADA using the OPC servers. Like SCADA is a supervisory control and data acquisition system. Okay, now that the PLC receives temperature from level 0, and then then PLC will send this data to the SCADA system. So to send that particular information to the SCADA system, we require protocol or a channel. So this level 1.5 we can consider this as a communication gateway. Similarly, at level 2, that is what we call in the industrial control system as a supervisory layer, because this is the layer where decision is happening. Like for example, let us suppose the temperature is 75, which is beyond the threshold. Then that PLC just send this data to the SCADA system via OPC servers or different protocol gateway. Then this SCADA calculate that the temperature is within the threshold or beyond the threshold. If it is beyond the threshold, then a SCADA system send a control signal to the PLC that you must have to switch off the temperature, or means lower down the temperature, and then that PLC will send to the actuators. And at the supervisory level, SCADA is one component, HMI is there, alarm server is there, energy management server is there, distribution management server is there, automatic generation control is there. So SCADA is one component, but apart from SCADA, there are multiple different components is available at this particular supervisory layer. Okay, and it depends on what kind of industries you are talking about. At layer now when we are moving to the layer 2.5, layer 2.5 talk about the operational layer. So what is happening in this particular layer handles the production optimization, maintenance and analytics, that what is produced, what was the fault, everything is recorded at this particular layer. That is called operational layer. Now historian store the 5 years of plant temperature, so that data you can access from this particular historian. Historian is one. There is MES, that is called manufacturing execution system, APC, that advanced process control, predictive maintenance, analytics. So these are the component at layer 2.5, and different server we are using at each layer. Now when we are talking about the level 3, that is called OT infrastructure plus cyber security. So this level 3 provide IT services and cyber security for the OT environment. So this level 3 is very important. This provide IT services and cyber security for OT environment. Like which components we are using here? So this component, now you can consider that AD means Active Directory, domain name server, NTP server, SIEM, IDS, antivirus, patch management, PAM, SOAR, backup, NAS server. So these are the components we are using at this particular level. For example, SIEM collects the log from SCADA server, NTP synchronize time across all the PLCs. This is completely provide the IT services and cyber security to the complete this level 0 to level 2.5. Okay, now when we are talking about the level 3.5, where the virtualization comes into the picture, like provide the virtual virtual infrastructure and containers platform like VMware, Hyper-V, Kubernetes, Docker registry. So multiple SCADA technologies we can use. Like for example, multiple SCADA servers run on SCADA server runs as a virtual machine on a VMware EXI. Now next level is level 4, which is called industrial demilitarized zone, that is called DMZ. So this is the security buffer between the IT and OT part. The reason IT where there your like for example your consumption is your at your home you are using electricity. Now you have to pay, you pay directly to the website. So that is the IT part of that particular business, where your record is stored, your bill is getting generated, everything you are paying, but you are not directly communicating to the OT, where the electricity gets generated and how they are purchasing the electricity and all. So that industrial DMZ separate this IT part from OT. Now in this particular industrial DMZ, what kind of server we are using? That the jump server, VPN server, reverse proxy server, data diode, historian replication. And what is the purpose of this? The purpose is to prevent direct communication between the enterprise OT. So this acts as a bridge between this. So no one can cross, no unauthorized person can cross from the level 5 to the level 3 without having any proper validation. Level 5 is a business and cloud system operate here. Like for example, that ERP system, business intelligence, data lake, AI inference, digital twin, IoT platform. ERP receive production number from MES. This is what we can do, what we are doing at different layer. If we'll talk about the complete flow, so level 0, temperature sensor measures the turbine heat. Level 1, PLC process the temperature value. Level 1.5, OPC server convert that PLC protocol to the SCADA readable form. Now that level 2, SCADA display the turbine temperature to the operator. At level 2.5, historian store the turbine data in the storage. Level 3, SIEM monitors the cybersecurity event. Now level 4 or 3.5, where the hypervisor or the multiple machines are operating. At the level 4 industrial DMZ, data replicated securely to the enterprise network through the DMZ. Now that data is directly replicated to the enterprise or the head office for the further discussion. So that is all.